Namaste. All right. Hey, good morning, guys. All right. Today I wanted to talk about this morning. I want to talk about simple machines. All right. And what, in terms of physics, what a simple machine is, all right, is a device that gives. Well, it's a machine that has no moving parts. Okay. Well, I should say only like one moving part. Okay. It's not a complex machine like the motor in your car. A simple machine gives you a mechanical advantage. Write that down and know it. And what a mechanical advantage is the number of times that the machine multiplies the force that you put into it. All right. And that's what machines do. All right. They make us stronger. They augment our bodies. All right. If you think about what a front end loader can do, you can lift much more with that than you can with just your own body. All right. And that's why we, as human beings, and we're intelligent enough and clever enough to make machines. So let's look at what the simple machines are. Okay. There are 6 basic simple machines. Okay. And the first one is a lever. Okay. And we'll get into, because there are 3 types of levers, we'll get into that in a bit. All right. So, and a good example of a lever is, here's Mr. Crowbar. Okay. So, and you can use it to increase your strength and so on. We'll talk about that in a little bit. The second one is a wheel and axle. There's really no particular order to these things. All right. All right. So I'm just saying wheel and axle is number 2. Okay. The third simple machine is a pulley, which is basically a wheel and axle used to turn the direction of a rope or a series of ropes. Okay, so they're related to each other. The fourth one is an inclined plane or a ramp. Number 5 is a wedge. Now it's important to note that a wedge is really the same thing as an inclined plane or a ramp. Okay, it's just a mobile inclined plane. All right, so if you take, for example, here's a high place, and then you put a board over there to go up and push a box up to this height, which you can do it easier than if you were to lift it straight up, and that's one of the reasons human beings figured that out a long time ago. But if you solidify this, all right, now instead of just a board, you have a wedge. All right, and we'll talk about examples. Well, a wedge could be, for example, a very thin wedge would be a knife. Another example of a wedge that human beings use is an axe, something like that. Okay. So that's another example of that. All right, number 6, all right, the last one is a screw. And it's important to note that, like the wedge, the screw is actually an inclined plane. If you were to take a cylinder and you were to wrap an inclined plane around it, okay, and go around the back and then come up and then go around the back and then come up, you would get the threads of a screw. Okay, so a screw, a wedge, and an inclined plane are really variations of the same simple machine. Okay, so there you, and actually to go into that, if you take a look at this, a wheel and axle is just a round lever. So if you take a lever, and here's the fulcrum of the lever, okay, that's the point that it's balanced on or rotates around, and you were to make it go all the way around, and I'm trying to draw this on a chalkboard here, all right, you would get a wheel and axle, all right, which is also a pulley. So there's really only a lever and an inclined plane, and the others are variations of one of those 2, okay? All right, let's look at levers for a second. There are 3 classes of levers. All right, so, and the first is a first class lever. And a first class lever, here's a diagram for it. So basically, if you took a stick and then you put this is called a fulcrum. I'm not going to write it down just for the sake of room here, okay? And this part right here, okay, is your effort arm. So if you go from the fulcrum to where you push down on the stick. So let's say I'm trying to pry a rock out of the ground or something like that with this lever. If you go from here to where you exert your force, this is called the effort arm. And then from where the this part here is called your load. And this distance from the fulcrum to the load is called the load distance. Okay, so that's your load distance, effort distance. This is a fulcrum. What you're lifting is a load, and this would be your input force. The mechanical advantage, and I'm going to write down as MA. All right, the mechanical advantage of a lever, the amount of times it's going to multiply your strength. The way you get it, it's always your effort distance divided by your load distance. So, for example, let's say that we have an effort distance here. So we have a length of stick here, and let's say that this stick is 15 feet long. Okay, so we'll make this from here to here is 15 feet. Okay, and so we're going to put the fulcrum 5 feet away from our load. All right, so that would give you an effort distance of 10 feet and a load distance of 5 feet. So my effort distance would be 10. All right, my load distance would be 5. 10 divided by 5 is 2. No units on that. The units cancel out. Mechanical advantage, like coefficient of friction, is just a single number that tells you how much the machine will multiply your force. So this particular lever configured this way will give me a mechanical advantage of 2. What does that mean? Well, that means if I push down with 10 pounds of force on this end, I'll get 10 times 2, or 20 pounds of force on this end, like that. Okay, so, and that's what it means. Okay, that's what mechanical advantage means. So, so it's the amount of times the machine multiplies the force you put into it. So if my effort force, Fe, is 10, and I have mechanical advantage of 2, then my force that I can lift, all right, the load I can lift, force load is 10 times 2. Okay. Now, it's important to note that the trade-off is distance. Nature never gives you something for nothing. Nature says, yes, you can increase your strength, but if you think about it, so here's your lever right here, right? Okay, so you can increase your force 2 times, but you have to exert your force through twice as much distance as this actually goes up. Okay, and that's the trade-off. So the trade-off with any machine, and for you future engineers out there, you need to know that the trade-off with any machine is always force for distance. Okay, so there you have it. You can be stronger, but you're going to have to exert your weaker force to get a stronger force out of it through a longer distance. All right. Okay, so that's a first-class lever. A second-class lever looks like this. So a second class, okay, is if you took the fulcrum and you put it on the end like that. And then you had, for example, a input force right there. And then let's say I'm lifting an object right there. The load and the effort are still the same, all right, in terms of definition. So here my effort goes from where I'm exerting the load, or where the fulcrum is, to where I'm exerting the force. So that's my effort. And then my load distance is to where the load is from the fulcrum. So there's my load. And it's the same thing. All right. A good example of a second-class lever that you probably have around your house is a wheelbarrow. Okay. So you put the wheel, there. Okay. The fulcrum is actually the axle of the wheel, and then you have your like container on top to put stuff in, and then there's you at the end of the wheelbarrow, kind of lifting it up. And obviously, if you've ever used a wheelbarrow, you can lift a lot more stuff with a wheelbarrow than if you just had to try and pick it up by yourself. Okay, it increases your strength. So that's what it does. All right, so a third-class lever is a little bit different. All right, so you don't get a mechanical advantage from a third-class lever. Okay, so what you get is a trade-off in speed. So I would have my fulcrum here, my stick there. I would put my effort. Your effort is actually shorter. And then you would have your load out there. And it's actually a little bit harder to move the load, all right? And you would say, why would you do this? Well, because what you get out of it is you get an increase in speed. So a good example of a third-class lever would be things we see in sports, like a lacrosse stick, where you can take and you put the ball in there and you whip it. This is a third-class lever. If you notice, so here's my pivot point right here, here's my effort, and then I put whatever I'm trying to throw over here. And for some of you guys, we're going to do this for the Physics Olympics. You're doing the siege engine. Siege engine is an example of a third-class lever. Okay, so you get something like that. By the way, just to go through the levers, I'm going to use my favorite type of lever, which is a crowbar. Okay, so if I configure it like this way, all right, and you see a crowbar is designed to do this, all right, it has a natural curve, and that curve in there is actually a fulcrum. And so if I'm trying to pry something with this end right here, all right, so here's my effort distance from here to where my hand is up here. It's tough to fit it all in the camera like that, okay? And my load distance is there, and look how short it is, okay? And this distance right here where my hand is got to be about 5 times longer than this. So this this particular crowbar will probably give me a mechanical advantage when I try and pry something out of about 5, which means that if I push down on this end with 10 pounds, I'll get a good 50 pounds out of the other end, which is why a crowbar works. Now you can see, however, that the trade-off again is distance. So if I try and as I move the long arm, look at how far I'm moving the long arm, and then this part only here only move like maybe an inch. Okay, so watch that again. Okay, so I increase my force and multiply my force, but the trade-off was distance. All right, nature never gives you something for nothing. Here's if I configure the crowbar this way, I can get a second-class lever. So I jam this into like a doorway or something like that. I'm trying to pry it open, okay, and then you would have like whatever you're trying to lift or move over here, and then your effort is there, and there you go. So there's your pivot point right there, okay, your load is over there, and so on. And obviously, because we know how to use this thing and we're proficient, I could use this as a third-class lever. Basically, here is my, all right, here's the end I'm trying to move. Here's my pivot point. My load is actually the head of the crowbar, and when I'm trying to hit and bash in the brains of a zombie, this works really well because I can get this moving pretty fast and thus crush through the skull and so on. All right, and remember to always use the blunt end. You don't want to use this end when you're hitting a zombie because it might get stuck in the skull, and as Grandma Golis would say, and then what are you going to do? You know, so and that can be a problem. All right, so anyway, the mechanical advantage is always the effort over the load. Let me just close up quickly here, all right, by giving you a couple more things. The mechanical advantage, if you're talking about so this is a ramp or an inclined plane in physics. The mechanical advantage, all right, is always the length of the ramp or the inclined plane versus the height that you're lifting the object, okay? So your MA for a ramp is the length versus the height. And the mechanical advantage for a wheel and axle, okay, so here's a wheel and axle, all right, so here's the axle, okay, circle, and the axle's got a little diameter, and the wheel itself has I'm going to draw it this way, has a big diameter. The mechanical advantage for a wheel and axle is the big diameter divided by the little diameter. And these are easy and similar calculations as with the lever, all right? You just divide two numbers. It's usually the bigger number by the smaller number, and so on, all right? Okay, I'm going to close, oh yeah, and the mechanical advantage for a pulley is the number of strings. You would count the number of strings that is pulling up the object, okay? I can get into that a little bit later. All right, but anyway, okay. So I'm going to close this for now. You have a basic kind of concept of simple machines. All right, I'm going to do follow-up videos on this because there's a little bit more to say about this, including the topic of efficiency. But so far, suffice to say, you got this for now. All right, okay. So remember to keep your crowbar close to you. I always do. And to enjoy your apocalypse. Goal is out.